Today we're going to be talking about Earth's oceans. And I thought it would be really cool. I was actually reading all about this stuff earlier today, so it'd be really cool to go through like the underworld volcanoes that there are, the ocean currents, how they work, some alien seas that are out there, and potentially ancient mysteries. So, with all that said, let's go ahead and get started. So, to kind of begin with what I was looking into in terms of research, so there are a whole bunch of underwater volcanoes on Earth. In fact, 80% of Earth's volcanoes are actually underwater along the mid-ocean ridges. And what I thought was really cool was actually this image on the right here called the Pacific Ring of Fire. And what this is like most of the Earth's volcanoes are actually along this ring. And I thought that was just really neat. Now, what is even more interesting, and this will be important in like a couple later slides here, but with the thing with the underwater volcanoes is that they are hydrothermal vents and they eject superheated mineral-rich water. And the reason this is important is because down here, near these vents, there are actually living organisms, right? And those organisms, they can't depend on sunlight. It's just too like low for them. Like the sunlight literally cannot reach them where these are at. So the organisms that are down here had to figure out another way to survive. And for them to do that, they actually take the minerals that are ejected from the hydrothermal vents, and they are able to use what's called chemosynthesis to actually take those minerals into their body, and they have bacteria in their body that will then break that material down into energy, and that energy then makes glucose, which is like, you know, how they survive and how they keep living. And also, it's just kind of fun, like a fun little thing is that lava, whenever it comes out of these hydrothermal vents, it cools really rapidly. And like, if you like look up a video for it, it literally looks like toothpaste coming out of the ground. It's super weird. But here's an example of a hydrothermal vent in action, so you can kind of like see that there's already a whole bunch of material in the air just kind of floating around. And on this next slide here, these little guys are one example of something that will actually take in that material and convert it in their body. So this is the process known as chemosynthesis. I kind of mentioned this a second ago, but what this is it takes the hydrogen sulfide or methane that is brought out by these hydrothermal vents, and it actually takes it into their bodies where bacteria will break it down, oxidize the chemicals, and it will release electrons, which then makes the sugars, and it feeds the deep sea life. Now, a couple things here is that the two worms that are in this image are actually usually what you find around these vents. I think there's also like mussels and things as well that feed on this. And then other like organisms will come along, like crabs or like fish or something, and will actually feed on these guys. And that's actually how life evolved at the bottom of the sea, is that it is all depending on this. And something I didn't like, I really don't like these things, these two worms, they kind of like creep me out. These are not plants. And that took me like, it took me a second to like understand this, is these are actually living organisms that act like plants in a certain way. Like they can swim, and I hate that. Because if I saw that at the bottom of the ocean, I would literally freak out. I hate it so much forever. But yeah, they can literally swim to like vents, and then once they find a vent, they'll actually like attach down onto it. They have like something that comes out of their body that they can latch onto the side of these vents and feed on. So these guys are actually super important to the life cycle down there. And you can actually see it looks like crabs in the background, or like some sort of crustacean back there. So that's chemosynthesis. So instead of photosynthesis that we have up on land, where, you know, sun comes to the plants, they go through the chloroplast, and the chloroplasts make energy for the plants. The plants then, you know, feed animals feed bigger animals. It's the same overall process, but it just happens at the bottom of the ocean where sunlight can't reach. I think that's what's really interesting. And the reason this is even more interesting, right, is because this process does not necessarily have to take place on Earth. Is realized that this is chemosynthesis So what's really cool is it's not specific to Earth. It's actually a held belief right now that alien oceans could have the same overall process. And so we have Europa on the left here. We got Ganymede, Titan, Enceladus, and just like basically each of them could have this potential because these are moons of like I believe I know Europa is obviously a moon of Jupiter. You can see Jupiter in the background. But I know there's also the 2 moons are from Titan and 2 moons are from Jupiter. But they're ice moons. And what this means is that their outer layer is comprised almost entirely of ice, like a thick layer of ice. And then as you go deeper, it's like pretty deep. It's like kilometers we're talking about. So, but once you go deep enough, you actually can find that there is an ocean world completely underneath this. So literally think Subnautica, and it's like kind of like that except freezing. So maybe Subnautica below zero would be more of an accurate representation. But so there's these entire worlds of ice. And what's really interesting is that it's like something with how... Hello, Kiku, how are you? But what was interesting is like depending on how Jupiter pulls like Europa, there can actually be like a reaction that causes these geysers to pop out of the core and actually heat the ocean below. And so if we go back to Chemosynthesis, then this is like could be how life evolves on these different moons. I'm doing really good. Thank you for asking. Rumba now. There we go. So the next thing I want to talk about is like speaking of moons, right? There's also tidal bulges. So what a tidal bulge is if you've ever heard of like high or low tide, that's kind of where this comes from. And I call you teacher, lol. If I teach you something, then we've won, and sure. But so let's see. Especially approaches from gravity. So literally, these are caused by the moon and the sun, or like if you've seen Interstellar, and I'm like trying not to like spoil too much, but there is a little something that happens in Interstellar with a black hole in the waves. But as the moon revolves around the Earth, it will actually cause a pull on the ocean, and that pull it creates one of the bulges. Now, what's interesting is that there's actually two. There's actually two. So you have the one bulge that's being pulled towards the moon by gravity, but then the other one that's not caused by gravity is actually caused by the lack of gravity from the moon. So as the how can I explain this? So the first bulge is caused by the moon. The second one, because the force of gravity from the moon is weaker because it's on the other side of the planet, is actually caused by centrifugal force. So what that is as imagine Earth and the moon are attached by like a stick, and the center of where they rotate around each other is closer to the Earth, but not quite the center. So as they're like rotating and dancing through the night sky, there's actually a force that makes the oceans kind of like spin against each other on the other side. And since the gravity from the moon is weaker on that side, the centrifugal force actually overpowers that net loss and creates another bulge, because it's just like that spin is what's causing it. Well, actually, just this really quick as well. There we go. And I thought that was pretty cool. Now on Earth, it usually like our tides are usually, or I'm sorry, not our tides. The bulge of the tidal bulge is about 1 to 2 meters, but it can get up to 60 meters. So it's like it's literally a big wall of water that is caused by that. The sun can also cause this a bit, but it's not near as strong. The only time that you'll really see a significant difference whenever it comes to the sun interacting with the tides is actually whenever the sun and the moon align. So the sun and the moon and the Earth align, and that will give a little extra oomph to the tides themselves. And then as far as Interstellar goes, one of the planets that they visited was near a black hole, and the pull of gravity was so intense from the black hole that it actually caused these massive walls of water. What I also thought was interesting in you may have seen this like on YouTube or something, just like sometimes, I don't know about you, but sometimes I get like those Northern Sea like YouTube shorts with the yo-ho and everything. But one of the ones I saw was actually showing two oceans that met in the middle, and there was like a clean line between the two. Now, that is pretty much not true. I mean, there are boundaries between different oceans, but it's not going to be like as clear cut as that one was. But there are two ways that the oceans can separate. The one is the Halocline, which is a boundary between between salty and fresh water, and it's caused by the differences in salinity and the temperature. And like that's kind of the image in the bottom left here. So the interesting thing with the Halocline is that it can create lakes in the ocean, and that you can actually like go into, because what it is there's the density of water is different. So the water on top is a lot less dense, like the salt content in the water. So the more salt that you have mixed in with the water and the more diffused it is in the water, then it will make it like a denser overall like composition. But yeah, so like if you see the guy here kind of swimming into that water is more dense because of like the high salt concentration. And I believe it can also be like different materials too. So like sulfur, I think, can also mix into it. But yeah, I believe that's what's meant by salinity. As for thermo, so this is the mixture between hot and cold water. So it's usually like a pretty significant change in temperature. So if you have like a hot top of water and then a cold bottom of water, there's going to be a layer in between where they just don't quite mix, just because there's a significant difference. And that causes a little like separation of sorts. Like you can see on the right image, there's actually that light beam that goes through. And that is actually the layer between the two. And I thought this was really cool because like I didn't know what this was called whenever I was playing Subnautica, like the first game. And as you go into the Lost River, there's a lot of these different poles under the ocean, and like the Brine Poles, and it's a halocline. That's actually what it was. So I was like, oh, okay, wait, I know that. Where that layer is, it's like pretty much all over the planet. So it really depends on where you are, like on the Earth, for it to be like, there's no like set layer, right? It's just kind of dependent. Like if you're in Antarctica, it may be higher just because the water is colder. But if you're more towards the tropics, it could be lower. So it varies. But that's a good question. I appreciate that. But I'm curious about that too. I'll have to look into that, see if there is like a average or something. And so kind of while we're talking about like ocean currents and how they interact, or I'm sorry, not ocean currents, but like the halocline and thermocline, like how oceans interact with each other. We obviously have to talk about like ocean currents and gyres. So gyres are large rotating ocean current systems, and one of the best like examples of these is that you can actually see with like Finding Nemo. They go through a big ocean current, and like it's a gyre as well. So these are driven by like several different factors, like the wind that goes across the Earth, the actual rotation that as we're going, and like how the land masses are hitting them. So this only says that the East Australian current, or the EAC, is real and fast. The actual speed of it is 9 kilometers an hour, or 5 knots. So it's pretty, like, for water, like just like hanging out, that's pretty quick. And they do, fish and sea turtles do use currents to migrate. It's not typically like a big fish. It would be like a whale wouldn't use it, for example, or like maybe a shark or something. It would be more for like smaller fish, plankton, bacteria, shrimp, things like that is what would typically use it. On Instagram, yeah, if you follow me, Mira on Instagram, certainly I can follow up with anything. But thank you for stopping by. I really appreciate it. And I'll do my best to answer any questions you have as well. One of the other things that I wanted to mention, and I actually just found out about this earlier today, is that if I go back up here, the gyres in that top left image, what they do is they actually can like move and bend and shift around, and in doing so, whenever garbage is dumped into the ocean, which is incredibly unfortunate, but as it's dumped in the ocean, it's been gathered around. So like in China and like like Japan, Korea, things like that, there was an eastern garbage patch, and then in like California and like parts of Canada, Alaska, there's a I mix those two. I think there's a western garbage patch. So anyways, there's two garbage patches on the Pacific Ocean, and the microplastics that are in the ocean, they went onto these gyres and like spun around and like got together, and they created what is called the Great Pacific Garbage Patch. Now, what that means is like if you were to go out to, like, you can see it's pretty close to Hawaii. If you were to go to Hawaii, you're not going to see like 3 France's worth of garbage floating around. That's not like the actual, like, you won't see that. What it is, it's microplastics that are like about the size of like a fingernail, and there's just a whole bunch of them. We're talking like, I think the last recorded measurement was like 1 trillion tons of garbage or something to that effect. So that is really unfortunate, and it's a cause of these it's caused, of course, by humans polluting the oceans, but the consequence of them going through gyres is that this has been created. So between California and Hawaii is where this will land. But speaking of like things getting moved around throughout the oceans, I thought it'd be kind of cool to talk about the Thermohaline Circulation, which is the ocean conveyor of like the Earth. So basically what this is that these are currents that go all over the planet, and they're powered by temperature and salinity. And so as like the cold, salty water, it sinks down and it moves, like it gets pushed along the bottom of the ocean floor, it will reach a climate that gets warm and like hotter. And as that heat reaches that cold water, it'll rise back up. And this, like, as this is moving around, it creates kind of like a pressure flow that pushes it forward. And that's how the currents are done. So I thought that was really interesting. What I thought was even more interesting is if you were to take 1 point on this conveyor here, you were to take 1 point. To go from that point back, like all the way, like to complete a loop back to that point, is 1,000 years. Like, that is crazy to me. Like, I know, like, I mean, 5 miles per hour is not a lot whenever you're traveling the entire globe, or on, sorry, 5 knots, and 5 knots is not fast whenever you're traveling the entire globe. But 1,000 years, that's crazy. And one thing I did see is that disruptions in the thermohaline circulation could actually cause some major climate problems. And so what this means is that the water that is flowing along the thermohaline circulation would actually, it wouldn't move as much as it would originally. So the warm water that'd be going up to northern Europe, so like, you know, around Sweden and those different areas, it wouldn't get up there. And because that warm water wouldn't reach those northern regions, it would freeze. And similarly, the like cold water that would typically go to the tropics would not reach it. So it'd be constantly hot water, and it would start to burn, basically. And because there's not that material that's floating around and going with conveyor and like all this different, you know, like resources from the ecosystem like point of view, fish populations would crash. And if fish populations crash, well, then that's just like a butterfly effect, right? So what causes this thermohaline disruption? Because this is like a known thing. This is what this image is up here, is the melting of the ice caps is one potential way that the thermohaline circulation could get disrupted. Because what this is by melting ice caps, this is introducing a ton of fresh water into salty water. And by introducing like a ton of fresh water into salty water, we're actually diluting the saline content in the water. And this makes it so that that process that I just mentioned, where it's like the salty cold water is going down and like the warm not so salty water is going up, this just makes it so that it's constantly non-salty water, and so it's not as dense, not as heavy. It can't fall to the bottom of the ocean. That gets rid of the currents, and now we're cooked. So it's a pretty big deal. And this is kind of like what the whole, global warming thing is about, is like trying to make sure that this doesn't happen. So what I thought would be some like kind of interesting facts at the end here is that so I'm just going to go from like top left to bottom right. And one of the interesting facts is that the ocean is so challenging to actually explore that we have seen more of the moon. We have mapped more of the moon than the ocean. Just for like a number to put to it, we have 80% of Earth's ocean we have no idea about whatsoever. It's like a complete mystery. We just can't reach it. That is like really interesting, but also like absolutely terrifying because who knows what's down there. So it's like, oh, it's wild. But yes, we know more about our own moon than we know about our own ocean. One of the deepest living fish on Earth is the Mariana snailfish. And that's that little guy on the right, in the middle right there. That I think is just like, I think is really cute. Like for some reason, I don't know. He seems like a little guy. And I love him. He's fantastic. But they live 27,000 feet below the ocean's like top level. And they're boneless and translucent. I can't talk today. But and they just kind of vibe. I don't know. I think they look really cool. They're not actually that big. They're like, I think a couple inches across. Like, I think it was like 4 to 6 inches in length. And yeah, they're just dudes. They just live on the ocean floor. They're just having a good old time. I also thought this was interesting is that every iceberg I have ever seen has been like blue or like white or something like that. But you can actually have a green iceberg. And what that is caused by is when algae gets trapped in the water and it freezes and it builds upon itself, it can actually turn the iceberg green. So I thought that was like kind of like, I've never seen that. So I wanted to make sure to include that because I thought it was really interesting. Going to the bottom left now, let me step back up here so I can show the whole image. Boop, boop, boop. So this right here, the Thermohaline Circulation, this would not work without this last piece here, which is the Antarctic Circumpolar Current. And what this does for the Thermohaline Circulation is it actually allows those currents that would be on the rest of the world to meet at a single point and revolve around the rest of the Earth. So it is like the meeting grounds of all the currents. So without it, we wouldn't have what we would have normally. I don't like this one in the middle here on the bottom. There is what is called a zombie zone in the ocean. And what this is that there is a zone that has no oxygen, is completely, or I shouldn't say completely, but it is like 90% devoid of life. And the things that do actually exist in this zone, like, are extremely slow moving, which is where the zombie term comes from. But yeah, this like, the Dead Sea, I believe, is one of them. I believe. I'll need to double check on that. But because the salt content is so high in this area, literally nothing can survive except for like, organisms that are used to the extreme environment. But yeah, there's literally just dead seas that are around, and that's wild to me. In the bottom right image, I couldn't really find a good image for this, as it is not something that is necessarily known, but there is, or rather has been, several loud sounds in the ocean. So the thing is with sound in the ocean is that sound travels 4 times faster in water than it does like in open air. And as the marine people are like examining these sounds, they can hear weird things sometimes. There's actually like a lot of really good YouTube videos about like the weird sounds that people have heard. And one of them is called the bloop. And it is like, they said it could be like this massive whale then existed, I believe, somewhere off the coast of, I want to say, either South America or or North America, but I believe it was in the Pacific Ocean towards Antarctica. But they heard this massive sound that sounded kind of like a whale call almost, but it wasn't, and it was never found out what it was, and I believe they heard it like 2 or 3 times before it just went like silent. And it's just like, that is so scary because we don't know what it is. It could have been, honestly, what could have been is it could have been like continental shells like grinding against each other. It could have been like underwater, thermo vents or something. It could have been something like that. Or it could have been a giant fish. Like something could be out there because like there could be something that grew to the size of this container, and we are talking something that's, hundreds if not thousands of miles wide. That could be a big fish. So that was the main thing I had for today in terms of the interesting, like, the galactic curiosities for today. So does anyone have any questions about anything, or like anything that you thought was interesting from this, and like maybe something you learned? As far as my stuff, honestly, most of it is really new to me, really interesting. So I don't know if I would say that there's one thing I thought was particularly I guess the one thing that stood out actually was like the tidal bulges was I thought was really interesting, because like with the when the Earth and the Moon rotate, that point that they rotate around is called the barycenter. And it took me literally, I had to sit there and like keep going over how that worked, because my head would not wrap around how it worked, and it was just like I just didn't get it. But I thought that was really cool. The idea that those thermo vents that like feed the material into the ocean at the bottom of the ocean where sunlight can't reach is also really interesting, because this could be something that could apply to those moons, right? So like Europa, this could be literally the potential of life could be there, because we have that material and we have like the heat and everything. So we have the foundation for like energy to be generated. If life were to evolve there, it has, there's a potential. So, and I think that's like one of the reasons that NASA is sending a satellite to Europa. I believe that's supposed to either already launched or it's going to be launching soon. But I believe that's their Clipper mission. But then I think that's one of the reasons they're looking at it, because there's that potential. So you would have to be able to, of course, see past the ice that is like that ice layer that's on top. But if you were to actually be able to see into the oceans below, there is a chance that life could exist. And take that for what you will. Because if life does exist, then now we're talking about an ocean world, and I played Subnautica, so I know what that could imply. And yeah, so it's really cool. I really like this as like a thought, just something to think about, something to learn about, and this is like, there's a lot of really cool stuff in this that I really liked learning, so it was overall really solid, I would say. But yeah, so if nobody has any questions, or if you do have questions, maybe if you're watching this later, definitely make sure to reach out to me on any of my social medias. It's pretty much all at Mira. So if you have any questions or just want to like talk about it, please let me know.